Hello my dear students, good morning. Now we will discuss about sodium carbonate Na2CO3 and which we call as a washing soda, and there is a difference between sodium carbonate and washing soda. When we call the particular as a washing soda means decahydrated, means 10 water molecules should present. Decahydrated sodium carbonate is called washing soda. Anhydrated form means no water, then only sodium carbonate is present, then that called as sodium carbonate simply. Okay, sodium carbonate is not a washing soda. Decahydrated sodium carbonate is called washing soda. Now let's see the preparations of this sodium carbonate one by one. In that, first one is the solvase process. In that, raw materials means what are the starting materials required to prepare sodium carbonate, we have to know first. CaCO3, limestone, CaCO3, okay, and we will take ammonia and brine solution, actually NaCl aqueous. Okay, so CaCO3, ammonia and brine solution we will take. So actually what will be the first step in this solvase process? CaCO3, first it will dissociate as CaO solid and CO2. This reaction is known for you. In equilibrium we learn many times. So CO2 gas. Okay, so CaCO3 equilibrium CaO plus CO2, because CO2 gas is required for us to have sodium carbonate. Okay, that's why we are taking calcium carbonate actually to generate CO2. Okay, so now the formed CO2, actually one by one, first this, and from this what will come? CO2 will come. CO2 will react with ammonia. So the next formed product will combine with NaCl like that. Okay, so now what happens? The formed CO2, second step, CO2 will combine with the water. Actually aqueous NaCl means water will be there. So water and ammonia NH3, then you will get NH4HCO3. Sir, you can write NH5 like that? No, it's NH4CO3 means ammonium bicarbonate. What you will have here? Ammonium bicarbonate. So here anion is NH4 plus and HCO3 minus. Bicarbonate means HCO3 minus actually. So in that way you will get ammonium bicarbonate. Okay, so that's why we are not writing NH5. Okay, so like that. Next is the third step. This formed NH4 HCO3 will combine with NaCl. NH4HCO3 will combine with NaCl, then NaHCO3 will get. Okay, so what happened? This NH4 plus you have here, that NH4 plus will be replaced by Na plus actually. So just exchange. Na plus is replacing NH4 plus. Now NaHCO3 will have. NaHCO3 plus what you will have there? Cl minus and NH4. So NH4Cl you are having. NH4Cl. Okay, so now next step, last and final, the formula, the sodium bicarbonate actually. This one is what? Sodium bicarbonate. Sodium bicarbonate. HCO3 minus is anion. NaHCO3. Okay, this on dissociation, on heating, you will get Na2CO3. Actually it can be reversible reaction. So Na2CO3 plus Na2CO3 plus H2O plus CO2. Reverse reaction also takes place but different condition. This is actually sodium bicarbonate preparation. Our next one is that only baking soda. Okay, so baking soda is sodium bicarbonate. Sodium carbonate actually decahydrated means we will hydrate, means for this we will add water. So it forms hydrated salt. Na2CO3.10H2O is what we call washing soda actually. So I repeat this always process. The starting materials important. Which of the following material used in solvay process they will ask. Otherwise, which of the following substance not involved in the solvay process they will ask. So these are important. Calcium carbonate used, ammonia used, NaCl used. Okay, so first calcium carbonate will dissociate as CaO and CO2, and next forward CO2. Actually CO2 is gas, so it is solid now, so it will deposit actually. So CO2, through that we will send ammonia, okay, water as well. So then you will get ammonium bicarbonate. Ammonium bicarbonate will react with this NaCl brine solution. Then you will get NaHCO3, sodium bicarbonate. Okay, sodium bicarbonate is actually baking soda. So this one on dissociation, you will get Na2CO3, water and CO2 like this. This is what solvase process. Next we have to discuss about Leblanc process, another second method. So first you have to write this. Okay, please have a screenshot and write down. Okay sir. Okay, next is we have to discuss about another actually. Okay, so solvay process over. Next one we have to discuss, that is Leblanc process. Same, we will prepare sodium carbonate. Leblanc's process for the preparation of sodium carbonate. Here also we use raw materials. What are the raw materials used here? Sodium chloride, same brine solution we use, and H2SO4, sulfuric acid. Okay, so here coke we use. Coke. What is the use of a coke? CO will come. NaCl and H2SO4 and coke we use here. Very important. So coke, actually what is the use? You will get carbon monoxide. Okay. So what is the process here actually? First NaCl will combine with H2SO4. You will get actually Na2SO4. Sodium sulfate. Two times actually happens. First sodium bisulfate, because here two hydrogens are there, no? So one sodium will replace one hydrogen. Two times you have, right, actually. So now actually what happened? So this. Okay, next here also that CaCO3 is required because carbonate. Like that. So let's see what happened now. This NaCl will react with H2SO4 and forms Na2SO4. Formed Na2SO4 will react with the coke, then you will get Na2S, sodium sulfide, and you will get carbon monoxide. What you will get? Carbon monoxide, sodium sulfide and carbon monoxide. This sodium Na2S, okay, now will react with this CaCO3. Now you will get what, you know? So third reaction, I think so. Third reaction, Na2CO3 plus CaS, calcium sulfide. Okay, this is one more preparation which we call Leblanc process actually. Which we have Na2CO3. Na2CO3 and CS we call as black ash. Black ash actually. So this is one more preparation. Here what are the raw materials we use? NaCl, H2SO4, coke and calcium carbonate actually. Hope you understood. So what happened first? These two will react. See, one by one sequence. NaCl with H2SO4. First actually two reactions I have tried, but no need. First sodium bisulfide will form. Bisulfate, sorry. So NaHSO4 will form because two hydrogens are there, no? So H2SO4 basicity is 2, everybody knows. So two hydrogens can be replaced by sodium. So Na2SO4 you will get. Na2SO4 with carbon, Na2S with CO. Na2S with CaCO3, you will have Na2CO3 plus calcium sulfide, we call as black ash. Okay, this CaCO3, as I said, on hydration means with water, when you send hydrated salt, you will get. When you add water on cooling, it forms Na2CO3 dot 10H2O, which we call as what? Washing soda. So this is about the Leblanc process. This also you write down. Actually, one more preparation is there, that is electrolysis of brine. Sir, electrolysis of brine solution gives NaOH, no sir? Yes, NaOH formed through that. If you send carbon dioxide, then you will get Na2CO3. So there are total 3 processes. So first process everybody knows. So as I said, Solvay's process, and the second one is the Leblanc process, and the third one is electrolysis of a brine followed by passing carbon dioxide. So third preparation is electrolysis of brine solution. So brine solution means everybody knows that is aqueous NaCl. So this aqueous NaCl on electrolysis, you will get NaOH. Everybody knows. So through electrolysis, or by using that brine solution electrolysis, by using Nelson cell or Kastner-Kellner cell, you will get NaOH. So the formed NaOH, through that, if you send carbon dioxide, you will get what? Na2CO3. That's it. So this is one of the process. NaOH, how you got? NaOH formed by Nelson cell, electrolysis of this aqueous NaCl. So brine solution giving NaOH on electrolysis. The formed NaOH, through that we are sending CO2 and you are getting Na2CO3 plus H2, like this. This is one of the preparation of this washing soda. Okay, come to the nature of, next preparations over, next nature of Na2CO3. Na2CO3 acidic ka basic ka? That's the question actually. Na2CO3, first of all, actually salt, but it have a basic nature. It's salt, but it have basic nature. How you are saying, sir? Suppose Na2CO3, if you are dissolving in water, it will form two. Actually, as it is salt, it forms acid and base actually. So it forms what? H2CO3. H2CO3 and 2 Na plus plus 2 OH minus, which combinedly called sodium hydroxide. So what you are having? Sodium hydroxide and H2CO3. H2CO3 is a weak acid. NaOH, as of we know, this is strong base. Certainly the particular Na2SO3 has what character? Basic character. Who is having basic character, sir? Sodium carbonate have basic character because it consists of two. Even you can say this Na plus and CO3 minus 2. CO3 minus 2 is a strong. That means it's a conjugate acid base theory. Do you know that? So from that also you can say. So it's a strong anion. So it's a weak acid. Strong conjugate base like that. It is weak. So NaOH is strong. Like that also you can say. Okay. So Na2CO3 has a basic character because in water, that is dissociating as ions Na plus and OH minus. In water, which ions are more? H2CO3 is a weak acid, so it cannot dissociate faster. So in water, what ions are there? OH minus ions are there. In water, OH minus concentration if more, that means what character that have? Basic character. Understood clearly? So Na2CO3 has basic character. So it's a forming weak acid, it is a carbonic acid, H2CO3. Weak acid, carbonic acid, H2CO3 and NaOH you are having. So in water, I repeat, what ions are there? hydroxide ions are there. Hydroxide ions means OH minus ions. So Na2CO3 has basic nature. Please write down this also. Na2CO3 has the basic character and all these things. It's forming carbonic acid. Write down its name. I have write carbonic acid. Carbonic acid which has less dissociation. Means in water it's not forming H plus ions. So as it is forming NaOH, NaOH can easily dissociate because it is a strong base. So in water OH minus ions are there. So there are three processes we have to have sodium carbonate. Last one, electrolysis. Hope you understood. That's very simple. First we will get sodium hydroxide by either Nelson cell or Kastner-Kellner cell. Okay. Through formed NaOH we will send carbon dioxide. Certainly we will have sodium carbonate actually. Now let's see some chemical properties. Chemical properties of sodium carbonate, Na2CO3. Na2CO3, as I said, it is a basic character, so it can react with acids. So first property is reaction with acids. So this kind of question, sodium carbonate with any kind of base, is the reaction possible? No. Why? Sodium carbonate itself has a basic character. Certainly it can react with some acids. So sodium carbonate can react with acids as it is having basic character. So I repeat last and final, sodium carbonate, even sodium bicarbonate also, they cannot react with bases. Why they cannot react with bases? Because themselves have a basic character. So that is the reason. Now that is only the reason, as they are basic, they can react with acids actually. Like HCl. HCl with sodium carbonate, what happened? Sodium carbonate properties we are learning. Na2CO3. 2 times you can write, or 1 time if you have, like this. Na, one hydrogen will replace. So NaHCO3 you will have. Hydrogen is replaced. Hydrogen replaced by sodium here. So that means what you are having? NaCl you are having. Okay. So like that. Here what's happening? Here reacting. Hydrogen replaced by sodium here. NaCl you are having. Okay. So now this can react actually again. NaHCO3 again react with HCl. Then you will get what? As I said, again sodium replace hydrogen from acid. Then you will get H2CO3 plus NaCl again. Like this. Okay. Like that, H2SO4 sulfuric acid when react with Na2CO3 if you see, then you will get what? Same story. Na2SO4 plus H2CO3, that we can call as CO2 plus H2. Here also H2CO3 means it can be right H2O plus CO2 like this. That's it, H2CO3. Because these are forming products in presence of strong acids, concentrated acids. Certainly H2CO3 can dissociate as H2O and CO2 like that. Here also you can write like that. Okay, first this will form and that further H2CO3 convert as H2 and CO2. Okay, even with the weak acids also can react because this is having strong base. Okay, so even like CH3COOH can react with Na2CO3. Certainly what you will get, it's very simple. 2 sodiums are there. So 2 hydrogens have to, 2 H plus ions have to be present actually. So that's why I just consider 2 moles. So here I'll get 2 moles of that CH3COONA. CH3COONA. So here hydrogen replaced by sodium. Then you will have here same story, H2O plus CO2 here. That's it. Got it everyone? So even weak acid, not only strong acid, weak acids also can react with sodium carbonate. That's why I given this reaction actually. So next one is reaction with CO2 actually. Okay, so as I said in previous, that sodium bicarbonate can convert to sodium carbonate, I said no. So that reaction actually. So reverse reaction part. Na2CO3 when react with the H2O and CO2. Okay, so carbon dioxide, moist CO2 we call. Moisture means water will be there or not. So Na2CO3 with a moist CO2, then you will get NaHCO3. Okay, so moist CO2 you have to write. Otherwise, may only write. Okay, sir. Sodium carbonate with CO2. Sodium carbonate with CO2. Moist CO2 means water also present. Then you will get sodium bicarbonate. Our next concept is this only. This is called washing soda. Okay. Sorry. This is baking soda. Sorry. That's a washing soda. Sodium carbonate is a washing soda. This is baking. Sorry. Baking soda. Sorry. Okay. So this is about one important, what we call chemical property. Two chemical properties. This is one and this is two. Next, reaction with even SiO2, silicon dioxide. So you will have Na2SiO3. Simple. So instead of carbon, you will get a silicon. That's it. Can you write reaction? So very simple. So you have to write all these things. Next chemical property, sodium carbonate reaction with what? Silicon dioxide. Okay. So what happened? Na2CO3, Na2SiO3 you will have. Next one is reaction with SiO2. What is SiO2 means? SiO2 means silicon dioxide. So Na2CO3 when react with Mr. SiO2, this is a small heating because SiO2 is a sand. So you will get Na2SiO3 plus CO2 will have. That's it. Okay, next is the fourth one, reaction with slaked lime, that is calcium hydroxide, CaOH twice. Reaction with the slaked lime, calcium hydroxide, you will get same, just exchange of ions. Sodium with OH you will have, because Na2CO3 will react with CaOH twice. That means what you will have? Exchange of ions. You can guess now what happens. What will happen? Sodium hydroxide, I said no. Exchange of ions. So OH and Na. Because here Na plus, here OH minus. 2 OH minus. Ca2 plus, CO3 minus 2. So you will get CaCO3. Reactions we can only actually construct. It's not a big matter. So you have no need to buy hat. Simple exchange of ions. Here carbon replaced by silicon. That's it. Okay. Next one is reaction with sulfur dioxide SO2. Same story. Carbon replaced by sulfur. Okay. Just like silicon. But when excess of sulfur reacted, then sodium thiosulfate will come. Sodium thiosulfate. I'll write that reaction. Na2CO3 when react with SO2, first you will get Na2SO3 plus CO2. This formed sodium sulfite. This is sodium sulfite, not sulfate. Sulfate means SO4. Sodium sulfite actually. This formed sodium sulfite Na2SO3 with sulfur, then you will get Na2H2O3. What is this? Sodium thiosulfate. You are having. Excuse me. Sodium thiosulfate. This is reaction with SiO2, reaction with the calcium hydroxide, reaction with sulfur dioxide. Hope you understood all these things. Please write down. And one more last and final chemical property, then sodium carbonate also will finish. So hope you written till here. So that notes also very important. And the last and final here I will give you, that is sixth. What is that sixth one? A reaction with nitrogen oxides. Nitrogen oxides. So actually nitrogen monoxide and nitrogen dioxide both will react actually. So what happens actually, sodium nitrate manufacturing, actually this one, sodium nitrite, NaNO2. Nitrate is different, NaNO3. So what you will have, Na2CO3 when react with NO and NO2, okay, on heating, Na2CO3 on heating with NO and NO2, you will get NaNO2, sodium nitrate, plus CO2. Carbon, the CO2 will come. Okay, so NaNO2 2 moles and carbon dioxide you will have. Understood, sir? So like this. And last and final, Na2CO3 when, means that particular washing soda, when you are heating about some 373 Kelvin like that, then first it loses 3 water molecules, Na2CO3.7H2O, and later on heating again you will get this Na2CO3. Okay, so these are somewhat chemical properties of sodium carbonate. Sodium bicarbonate means just reverse. Just go through our material or else textbook. Sodium bicarbonate, which we call baking soda. The preparation already completed because I given in previous. Sodium carbonate when react with water and CO2, you will get sodium bicarbonate. Its uses, okay, and that called baking soda, everything when we call, okay. So everything you can understand in that, okay. In our next class we will complete this alkaline earth metals also, and then we will discuss about hydrogen. Thank you.